So in this video, we're going to go through the open-ended sections of the final review. You have part one, the multiple choice in a previous video. Now you'll have both parts 2 and 3 will be in this one. So just scroll ahead if you need something from the last portion. So again, as I mentioned the other day, your open-ended part is 60 total points. Part 2, the shorter questions, those are 30, and then you have 40 with the longer open-ended ones. So first question, find the value of x when the area of the triangle is 42. So the fact that they use the word area, important. I know I'm going to have to use area formula. So in this case, it's a triangle, half base times height. You might have a square or a rectangle, maybe even a circle. So just be aware of those different area formulas. So I'm just going to fill in what I know. I know that is 42 is A. That's the area. I know it's 1/2. The base was 2x plus 8. And the height is x plus 3. You can go about solving this in a whole bunch of different ways. You can choose to multiply the polynomials, the binomials first, then distribute the half. You can get rid of the half first. You could distribute it first. It's completely up to you. Since I'm looking at this and I see the 2x plus 8 is fairly small or fairly even numbers, I could distribute that half to make things a little easier. A half times 2x is just x. Half times 8 is 4. You do not distribute to the one behind it, only the one touching. Now that's a lot easier for me to do. X plus 4 times x plus 3 is just simply x squared plus 7x plus 12. You FOIL that out, combine your like terms. Move the 42 over because I need to solve for x. And now I'm here. I need to factor that so I could solve it. So factors of negative 30 that add to 7. Well, positive 10 and negative 3 definitely multiply to negative 30. If I add them, I do get to a positive 7. So those are my factors. Okay, set each factor equal to 0 and solve. So I get x equals negative 10 and x equals 3. Okay, when I look at this though, x equals negative 10 doesn't work. If I was to plug that back in, say I plugged it into the height, negative 10 plus 3 is a negative 7. I can't have a negative height. So remember, that is what we call extraneous solutions. It's a solution to the mathematical problem, but not the actual problem at hand. So x equals 3 would be the value of x. All right, number 2, we're dividing now. So remember with division, you are going to take what you're dividing by, our divisor. That goes on the outside. Making sure that whatever you are dividing by or dividing into has every term possible, meaning if you're missing an x cubed or an x squared or an x or a constant, you got to put in a placeholder of a 0. With that in mind, when I put in the divisor, the dividend, I have x to the 4th, but I'm missing an x cubed, so I got to put a 0 as the placeholder. And then everything else lines up in place. Okay? All right, so in order to divide, we look at the first terms of each. What do I have to multiply an x squared by to turn it into an x to the 4th? Well, easy enough. That is going to be an x squared. You're going to take that and distribute. X squared times x squared is the x to the 4th I wanted. X squared times a negative x is a negative x cubed. X squared times 1 is a 1x squared. And again, notice how things lined up nice and neatly. Everything, fourths, cubes, squareds, were all there. You subtract down. Well, x to the 4th minus x to the 4th cancels. That's what you want to have happen. 0 minus a negative x cubed. Well, that's a positive x cubed. 2 minus x squared is a positive x squared. And then you drop down the next term. You repeat the process. So what do I have to multiply an x squared by to turn it into an x cubed? Well, that's an x. Distribute. X times x squared is the x cubed I want. X times a negative x is negative x squared. X times 1 is a positive x. Again, everything lined up nice and neat. I subtract. Cubes cancel. And then x squared minus a negative x squared, well, that's 2x squared because minus a negative, we're going to add it. Negative x minus another x is a negative 2x. Drop down that 5 and repeat one more time. So 2x squared. What do I have to multiply an x squared by to turn it into a 2x squared? Well, that's a 2. Distribute. 2 times x squared is a 2x squared. 2 times negative x is negative 2x. 2 times 1 is a positive 2. And subtract again. Cancel out. Negative 2x minus a negative 2x. Well, this also cancels out. It's a 0x. And then 5 minus 2 is a 3. There's your remainder. Now, when I write out my remainder, I'm not going to include that 0x because it's not really there. I just have the 3. So in the end, your answer is your quotient and your remainder together, meaning x squared plus x plus 2, that's the quotient. Those are all your full values. And I'm going to add to it the remainder over what I divided by. Your remainder always goes out over your divisor. Okay, and that is your division. Excuse me. All right, number 3, we got logs. So remember with logs, we have to come up with those log rules. One of them that we got to remember is as long as these are the same bases, log 3, and addition means I'm actually going to multiply the 2 arguments. So I'm going to rewrite this as log base 3 of x times 2x minus 15 equals 3. And I'll get back to that in a moment, but I want to get rid of the log first. So in order to get rid of the log, we raise it as a power. So a base 3 with the power of log 3 is going to get that to go away. Means this drops. And then 3 to the 3rd power is 27. I'm going to distribute. That's 2x squared minus 15x equals 27. Bring that 27 over. So I get one side to be 0. And now I got to factor that, or I got to solve it in some way. So you can choose to solve by either using factoring, this can factor, or you can use the quadratic formula, which I'll give you over here. So the quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. So you can use that. You could plug in your a, b, and c. For some of you, that may be easier. Or you can factor it. Factors are take the first and the last term, 2 times negative 27. That gets me a negative 54. Has to add up to the middle term of a negative 15. And then you have to play around with numbers. It does come out to negative 18 and a positive 3. So this factors. Okay. In the end, just to save us some room and some time, you would group these. So you would group first 2, last 2, take out what they have in common, and it's going to factor to 2x plus 3 and x minus 9. And you would set each of these equal to 0 and solve. And again, if you use the quadratic formula over here, you're going to get the same answers. You would find that x equals a negative 3/2 or negative 1.5, and x equals 9. Okay, so again, it's your decision. You can get it either way. For those of you who like to factor, you can do factoring. For those of you who want to use the quadratic formula because it's easier for you, that's fine. And in fact, let me show you guys how it would look filled in, just so if anybody did want to do that method, you would have negative of a negative 15 plus or minus the square root of negative 15 squared. Actually, let me move that over. Oops. So there's a room there. Okay. minus 4 times 2 times negative 27. I know I'm squeezing in there. All over 2 times 2. So it looks ugly. There's a lot of stuff happening there. But I promise you, you reduce it, you go step by step to complete it, you will get the same values. Okay. Now, actually, I need to go back because you can't have negative logs. So in fact, this is not one of my solutions. This is extraneous. So the only solution is x equals 9. Okay, so again, remember, you cannot have negative log values. All right, number 4. In the table, it says I is the imaginary unit. So you need to remember I is the square root of negative 1. That's your imaginary number. We want to select all cells in which the product, so multiplication, of the row and the column is a real number. So no i's. We don't want any i's in their final answer. Okay, so let's go through and do some multiplication. I times negative 3, well, that's a negative 3i. That's definitely not it. Negative 4 times negative 3 is a positive 12. That's one. So that's one of my values. Negative 2i times I. Well, that's going to get me negative 2i squared. So let's think about this. If I have an I squared, so I squared would be the same as the square root of negative 1 squared. And the square root of negative 1 squared, well, the square root and the square cancel. It is negative 1. So this would be the same as negative 2 times negative 1 or a positive 2. So this is actually one of those answers. It is a real number in the end. So if I have any I squareds, I can replace it with a negative 1 and get a real number. Negative 4 times negative 2i is an 8i. That's not real. I times 5 is 5i, not real. Negative 4 times 5, negative 20. That is real. I times I squared. Well, again, I already said I squared is negative 1. So why don't we use that? I times negative 1 is negative 1i. Not real. Negative 4 times negative 1 is a positive 4. That is real. Okay, so again, it's basically knowing the fact that if I have an I left over, that's an imaginary number. If I have an I squared, or really any even I exponent, you're going to end up with a real value. Okay. Number 5, 6 friends go to the movie theater, and how many different ways can they sit in a row of 6 empty seats? So this is a combination permutation problem, and you need to decide, does order matter or not? Remember, if order matters, that's a permutation. Order doesn't matter is a combination. If you are sitting in a seat, order matters. You can't sit in multiple seats at once. If I sit down first, I have now affected the order in which anyone else can sit in. So say I go in and I sit in the first seat, no one else can sit there. So I made the order matter. If I go in and I sit in the middle, no one can sit there. I've forced it for the order to matter. So this is a permutation. I have 6 seats and 6 friends that are going in the seats. So 6p6 comes up with 720 ways. Now, if you're using the calculator, I gave you guys the link for previously, but also if you put it in your calculator, remember the calculator gives you both the permutations and combinations. Permutations will give you 720. Combinations is going to come back as 1. You can't have one way for 6 people in seats. You know there's going to be multiple options there. So even if you weren't sure, when you put in the calculator, if you see a 1, go with the other option. And our last problem for the short answers is factoring. So we're going to factor this. We can see they are all divisible by 3. They all have an x, and the smallest x is an x squared. So we take that out. When we do, we divide them all. We get x to the 6th plus x to the 3rd minus 20. That can get factored further. I can take factors of negative 20 that add up to 1. That gets me a 5 and a negative 4. And the reason I can do that is because the middle term, its exponent, is half of my first term. As long as it's half, that means it could be split evenly. Meaning an x to the 6 can be split to an x cubed and an x cubed, which makes sense, and that's our middle term. And then I have the constant values. I have a positive 5 and a negative 4, and drop down that 3x squared. And that is our final factor. You do want to see if you can ever factor these binomials further, but they're cubes and they're not perfect cubes. 5 is not a perfect cube, and neither is 4. So we are done at that point. All right, so those are your short answer. Those are the quicker ones. And now our longer answers are where we're going to be split into multiple parts, A, B, C, Ds. Okay, so to go through those, we have a model rocket launching from the top of a building. So that's important. The height in the rocket above the ground is this equation, also important, where T is time since the rocket was launched and height is meters. We want to know the height of the building. So the fact that we're launching it from the top of the building, we're looking for the starting height. Well, the starting height is your y-intercept. It's when time is 0. So before I start anything, when time is 0, what is the height? Well, I'm going to put that. You can either put it in as 0 or just know that your constant is your y-intercept. This is your y-intercept. So the height is going to be 14. So the height of the building is 14 meters high. That is our answer to that part of the question. Now, part B says, what is the maximum height of the rocket? Yes, you can graph it and get the maximum height, but this is open-ended. I do require work. So unless you're going to screenshot and explain, I'm going to show you guys personally how to do it with mathematics. So remember our formula. I mentioned this in the previous video. For your max or min is negative b over 2a. That's the maximum. That's the x value of the max or the min. So I can really quickly and easily find this maximum. I'm going to use t because that's the variable we have. So negative b is 24 over 2 times your a, which is negative 6. And when you do that math, it's negative 24 over negative 12, which is 2. So that's the time. So the maximum time or maximum height occurs 2 seconds after it's launched. Then all you're going to do is take that time and plug it into your equation. So you put in 2 for all your t's. And that's just a matter of putting in your calculator, and you'll find that the height after 2 seconds is 38. So the maximum height is 38 meters. And lastly, part C, describe where the rocket is ascending and where the rocket's descending. Well, visually, I know that's a max. So that means my graph is going to look like this. I know that this is the graph, maxed height. So looking at it, I know I'm going up first and then I go down. So where is it ascending and where is it descending? Well, the rocket ascends for the first 2 seconds to a height of 38 meters. I'm just explaining what's happening. Then descends after that point, or that maximum point. Okay, so again, you're just describing in words what is happening here. Okay, using the fact that I know what a maximum is. I know it's going to go up, hit that point, and then down. All right, question 2. So I have a car purchased in the year 2010 for $26,000. Time of purchase, we were told by the dealer that the car's value would decrease by an estimated 12% each year. So that's going to be important. According to the dealership estimate, which are true? Okay, so what I'm going to do is actually start figuring out some year values here. Because if I read through it, we have the first year, we have 2 years, we have 3 years. So we are going to see, well, what does that mean? So if it's decreasing by 12% each year, Well, let's figure out what 12% of my 26,000 was. I'm going to do this up here. So at year 0, it was $26,000. I'm going to times that by 12%, and I get 3120. So that is the value's decrease. I'm decreasing to year 1, 3120. So year 1 is 26,000 minus 3,120. That gets me to 22,880. That's year 1. To figure out year 2, I have to do the same thing. I have to multiply year 1's value by 0.12. I'm going to get 2,745 and some change. So that's the decrease for year 2. So I'm going to take 22,880, subtract 2,745 and 60 cents, and I end up with 20,134 and 40 cents. Okay, and again, I can keep going, but I'm going to stop there and start looking at my options. So it says part A, answer A, the value will decrease by about 3120 in the first year. Well, that's true. That's what we found here, right? 3120, 3120. So that works. It's definitely A. After 2 years, the value will be about 20,134. Yeah, that's what I got. It had some change, but it says it's about, so that definitely worked too. So B, good. The value will increase by 36% in the first 3 years. Well, first of all, it's not even increasing, it's decreasing. So this is not it at all. It's not C. Part D, the rate of change of the value will increase over time. Again, we're not increasing, we're decreasing the whole time. So that can't be it. An exponential model provides the best fit of the estimated values. That is true. Anything that has a percent increase or decrease is an exponential function. It's an exponential growth or decay. So let's go through, because the next part actually leads us into writing the exponential function. And I'm giving you this to help. So it says, let the dealership's estimated dollar value for be t years after purchase be modeled by f of t equals a times b to the t, where a and b are constants. Write the equation of the estimated value. Well, a is your starting value. A is always your starting value. So what was our starting value? $26,000. So that's my A. B is your base. In this case, it's our decay rate, because it's decreasing. If it was something that was growing, it'd be a growth rate. So your decay rate is 1 minus R. If it's a growth, it's 1 plus R. Well, R was what? Here's R. R is 12%. So 1 minus R is 1 minus 0.12 or 0.88. And then I can put that all together in the equation I told you. So f of t equals $26,000 times 0.88 to the t. And that is our equation. And we're going to use that equation. Now for parts C and D. All right, part C, according to the model, what will be the value after 5 years? That's a time frame. Give your answer to the nearest dollar. Okay, so that's just a matter of plugging in a 5 into that equation. You would pull up your Desmos calculator, put a 5 in, put it in the calculator. To the nearest dollar, it comes out to be about $13,721. Make sure, nearest dollar, you round to whatever they tell you. If they say round to the penny, round to a penny. But here's a dollar. Okay, and according to the model, how many years will it be worth $10,000? So that's your function's worth. So that's your f of t. So this one's going to require a little bit more work. So $10,000 equals the 26,000, 0.88 t. We got to find t here. All right, so first thing we're going to do is divide both sides by 2,600. Get rid of the coefficient. Okay, so this comes out to 0.385 equals 0.88 t. Now we got to use logs. In order to get rid of this base, we're going to take log base 88. You're going to put that in your calculator, log base 0.88 of 0.385. You'll put it in your calculator, and you're going to find that it takes about 7.5 years. It didn't say round to the nearest year, and in fact, it's kind of hard to round. It's right in the middle. So you can leave it in the decimal form unless they tell you, or if it's very clear, it would round to, 8 years or 7 years. All right, that's probably going to be the longest and hardest question on the whole final. You're going to have one very similar to it. Instead of a car, it might be something else. Okay, but it's all done basically the same way. 3 should be one of the easiest ones. So number 3 talks about the degree, and there's really not a lot of work for any of this because they don't want to know what the answer of the addition, subtraction, multiplication is. They just want to know what the degree is. Remember that the degree is your highest exponent. So for G, the degree is 7. For H, the degree is 5. If I was to add those two polynomials together, remember you just combine like terms, and then you would put it in order. Well, the 4x to the 7 has nothing to combine with, and that's always going to be the biggest exponent whenever I add it to the h function, because nothing's bigger than that. So for A, the degree is 7. For B, same thing. If I was to subtract it, well, just subtracting, but still combining like terms, that degree of 7 is still going to be the highest exponent. I don't care what happens to its coefficient. The exponent's still going to be there. So the degree is 7 in this case. In part C, if I was to multiply these, well, I can do a little bit of work here. I'm not going to multiply the whole thing. But if I take 4x to the 7th, take that whole thing, and I times it by the second one, I'm not even going to write out the whole second problem. Remember when you multiply, right, we distribute. So we're going to end up multiplying the two bigger ones together. 4x to the 7th times 3x to the 5th is 12x, and you add your exponents. So it's 12x to the 12th. So in this case, when I multiply, I'm adding their exponents. I had to get a degree of 12. You don't even have to show that work over there. There's not a lot of work to show here. And in general now, it's knowing those general rules that when you add or subtract, you're just combining like terms. In general, G plus H and G minus H is the highest degree of the two polynomials. So in here, it does say G of X has a degree of M. So G goes with M and H goes with N. And they tell me M is bigger than N. So if I go back to my explanation here. So the highest degree of the two polynomials is M in this case. For multiplication, in general, G times H. The degree is the two degrees added together. M plus N. And that's really all there is to it for that one question. So that should be a nice, easy, quick, long response question for you guys. All right, number 5, back to some probability. I give you the cards to help you choose from and help you narrow things down in case you forgot what the deck of cards look like. So we have the probability of drawing a red jack. Well, here's the only options for red jacks. I got 2 of them, Jack of Hearts, Jack of Diamonds. So that is 2 out of 52. You can leave it like this. This is absolutely fine. You can reduce it. You can tell me it's 1 over 26. You can give me the percentage or the decimal. It doesn't matter to me. Most people are probably going to leave it in that first fraction just because it's safe. Okay, part B, find the probability that you draw a card, get a face card. You do not replace it, so that's important. And then your second card is a 4. All right, so the first thing I want to do is a face card. So that's all these over here. There are 12 of them all together, right? All of those, there's 12. So I have 12 out of the 52. Now, whatever it is I got, I kept it. It says you did not replace that card. Next thing you want to look at is the 4s. So here's all the 4s. There are 4 of them. So this fraction is going to be 4 because there's 4 cards, not because of the number. There's 4 cards. And it's out of 51 because I kept the card from my first pull. And again, you would multiply those together. I don't care if you give it to me as the fraction. 4 times 12 is 48 over 2652 when you multiply the denominators, or the percentage. It doesn't matter to me. Part C, now it says you're replacing the card. So the only difference is on your second draw, instead of being 4 out of 51, it's 4 out of 52 because I replaced the card. I put it back in the deck. So I still had 52 to choose from. And again, you would multiply it across. I don't care if you give it to me as a fraction or a decimal or a percentage. I will have all the options. And lastly, in part D, it says which were dependent and which were independent events. So part B was your dependent because you kept a card and you changed the total. Okay. And then obviously that would mean part C is independent. Because you replaced the card and kept the total the same. Right, you still had 52 each time. All right, and your last question. This question was on your SGOs, if you remember. A lot of people didn't answer it, so we're going to make sure we know how to answer it now. So volume, first of all, volume is length times width times height. All right, there's your length, your width, your height. It's the only volume you're going to need to know for this. You'll have another either cubic prism or rectangular prism. So it says, write a polynomial that you can use to find the value of x. Well, if it's 27 is the volume, that's going to go where the v was. So 27 equals all of these multiplied, length times width times height. Now you could write them all out. You could write them as cubed. That's your preference. But I do have to come up with a full polynomial that I'm going to use to solve. So I will need this multiplied out. So I'm going to just do that. Remember, you can only multiply 2 things at a time. So if I multiply the back 2, I would have x squared plus 2x plus 1. I could then multiply the x plus 1 into that. When you do that and you combine all your like terms, you end up with x cubed plus 3x squared plus 3x plus 1. And then I'm going to bring that 27 over. And this is what a lot of people forgot about when you did the SGOs. So you bring the 27 over because it has to be 0 in order for us to solve. All right. Part B says identify the possible rational roots to the equation. So there's the rational root theorem, but we don't have to use that. If you remember, I said we can use Desmos and the graph to help us out. So I pull up Desmos. I'm going to type in my equation, x cubed plus 3x squared plus 3x minus 26. And I can see I only got 1. I can zoom out as far as I want. Nothing's changing, right? So it's always going to be 2. So I'm going to go back here, and I'm going to say from the graph. X equals 2. Okay. From there, part C says use synthetic division. This is a part a lot of people skipped on the SGO. You have to use synthetic division. It says it. So you got to do it. So the 2 is what you're using. Then we're going to take each coefficient from the equation I came up with. So that is 1, 3, 3, and negative 26, and go through the synthetic division. Okay, so if we remember, we drop the first term. We're going to multiply. 2 times 1 is 2. Add down, we get 5. Repeat the process. 2 times 5 is 10. Add down, I get 13. 2 times 13 is 26. Add down, I get 0. If 0 is not your remainder, you did something wrong. It has to be 0. So this tells me that it is a root. It is a factor. The factor would be x minus 2, and then x squared plus 5x plus 13. And you could go through and continue solving this if you want. That's where your x equals 2 comes from. And you would find that when you try to solve this last one, it doesn't solve. You would try the discriminant based on that quadratic formula. And when you do that, 5 squared times 4 times 1 times 13, that comes out to a negative 27. So that doesn't work. It's an imaginary number. So x equals 2 is my solution. I was able to prove it from both the graph and using the synthetic division. That's the important parts of why I have C in there. And then lastly, what are the dimensions of the cube? Well, each side was x plus 1. So if I plug in that x I got, 2 plus 1 is 3. And that means my dimensions are 3 centimeter by 3 centimeter by 3 centimeter cube. Okay, so hopefully this cleared up some stuff for you guys and you're able to prep yourself and be ready for the final exam coming up. Good luck.